In this video, I'm going to explain what partial quotients, also referred to as Big 7, is. Partial quotients, also called Big 7, is a division strategy. For the first step in partial quotients is to draw a Big 7 shape. Then you multiply the divisor by something you're comfortable with. Then you subtract the dividend by your answer from part 2. Repeat the above steps until the number is less than the divisor, and add all the numbers together. And if you're watching this video, that might sound like a bunch of nonsense to you. So I'm going to explain this step by step with a couple problems for you. And then if you would like to see any other specific problems, you can post those in my comments. So I'll refer back to these steps as I go. The first problem we are going to solve together is 217 divided by 2. Now, the first step is to draw a Big 7. That's like people sometimes refer to this as Big 7. I like to refer to it as partial quotients because I like to use the vocabulary words. But do you see how we're drawing a big number 7 here? That's why people sometimes call it Big 7, okay? So you're going to put the 217 right in here, see? Right in there. And then put the 2 right over here, okay? So 2 divided by 217. Now I'm going to pause for a second and go over a few vocabulary words. This number right here, this 2, this is called a divisor, okay? Say it with me, divisor. This is the number that you are dividing this number by. It's the number of groups that you're putting this number in, okay? This number over here, this 217, this is called the dividend. It's the number that you are dividing by. The whole number you're dividing, and this is the number that you're dividing it by, okay? And then whatever our answer ends up being is going to be called the quotient. A quotient is the answer to a division equation, okay? All right, so I'll leave those there for a second. I'm going to make a duplicate of this page here. That way we can refer back to these words. But I don't want you to get too bogged down with these numbers, okay? So I'm going to erase these. And I'll refer back to those key vocabulary words as we go. Okay. So we're going to take our we drew our Big 7. We're going to multiply our divisor by something we're comfortable with, okay? So we're dividing 217 into 2 groups. Basically what we're saying is if we were to take this number 217 and divide it into 2 different groups, how much would be inside each of those groups? That's all that this means, okay? We want to know that let's say we had 217 cookies, we wanted to know, and we're dividing between myself and you, whoever you are watching right now, we want to know how many cookies we would each get, okay? That's what we're doing here. So what we're going to do, our first step, and what's really cool about partial quotients is that basically you're multiplying your way through dividing something. So you're dividing something by multiplying numbers you're already comfortable with, which I think is really cool, especially if you hear the word multiplication or division and you think, that sounds so scary. This is the least scary way to divide, okay? So we're going to take our 2 and we're going to multiply our 2 by something to get us somewhat close to 217, because our goal is to repeat all numbers until the number is less than the divisor. We want to get this 217 as low as possible, okay? So I know that 2 times 100 will give me 200. That really breaks this down, right? So 2 times 100 gives me 200. So then 200 goes down here, okay? Then you subtract. Subtract the dividend by your answer from part 2, okay? So 7 minus 0 is 7. 1 minus 0 is 1, and 2 minus 2 is 0, okay? So now we have 17. So now 2 times what would give me close to 17? Well, 2 times 8 gives me 16. That's pretty close to 17, isn't it? So now we're going to subtract. And then 7 minus 6 is 1. 1 minus 1 is 0. So what this means is these 100 and this 8, those are our quotients. We'll add those together, okay? And that's, I think a lot of us can do it in our head, right? 108. So that means, what this means here for our problem means that 217 broken into two groups would mean each group has 107, okay? And this 1 down here is a remainder. So we'll go back to our cookie scenario. Let's say I have 217 cookies. You and I are going to share all of them. These are your cookies. These are my cookies. And if we each broke up those cookies into two groups, we would each get 107, 108, I apologize. 108 cookies. We each get 108 cookies, and there'd be one little cookie left over. And we can double check this by going 108 plus 108 plus 1. Okay, so 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 1, 2, 17. And see how when we added all these numbers together, the 108 and the 1 and the 108, we got 217. That means we did the inverse operation. Okay, we did the reverse. Okay, all right. So that means that if that the answer to 217 divided by 2 is 108. Remainder 1. 108 with 1 left over. Okay? All right. We're going to do the same thing again with one more problem. So now we have a 3-digit number divided by a 2-digit number, okay? So the first step is to draw a big 7. So 367 divided by 14. So now you're going to say 14 times what gets me close to 367, okay? So we want to break this number down as small as we can. We might not get down to 0 because see here we had a 1 left over, so we had a remainder 1. If we can get this down to 0, that means we'll have no remainders, okay? So let's see, 14 times what? Well, I'm going to say, let's pretend like division is tricky for me and multiplication of high numbers is tricky for me. The numbers that are really safe for me, we'll pretend are 5s and 10s, numbers that I know off the top of my head, okay? So I'm going to just start with 10 because I feel comfortable multiplying 14 times 10, and that might be you out there, and that's okay. All right, so 140 times 10, or 14 times 10 is 140. So that will really break this number down, right? And you're going to subtract. So 7 minus 0 is 7. You can't, 4 minus 6 is 2. And then 1 minus 3 is 2. So now we have 227. And I'm just going to do the same number again. I'm going to do 10 again. I'm going to go 14 times 10. And I'm going to get 140 again. Okay. 7 minus 0 is 7. 4 minus 2, I can't do that. So I'm going to borrow from over here. That's going to become a 1. This is now going to become a 12. Okay, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, I just drew 1, 2, 3, 4, 5, 6, 7, 8 dots. So my answer right here is 8. Okay, and then 1 minus 1 is 0. So now I have 87. So now I want to know 14 times what gets me close to 87. I'm going to do 5 because I know 14 times 5 is 70, which is pretty close. You don't have to get exactly to the number because sometimes you just might not be able to. So I'm going to do 14 times 5, which gives me 70. 7 minus 0 is 7. And then 1, because 8 minus 7 is 1. Now, oh my gosh, I think to myself right away, 14 times 1 is 14. That's really close to 17. That's an easy thing for me to multiply. Put 14 down here. We're going to subtract. And I have 3. Okay? And look, I didn't get this down to 0 either. That means that this 3 right here is another example of having a remainder. So I'm going to explain this again, similar like I did last time. So let's say if we had 367 divided into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 groups. Okay, we're taking this number and we're dividing it into 14 groups. That means each person that we're giving, like let's say it's cookies again, you're going to add all these together. 10 plus 10 is 20, plus 5 plus 1 is 26, okay? 10, 20, 5, 26. That means each person here, if we're going to divide this up into 14 groups, each group will get 26 of whatever that is. Okay, and this 3 right here means they'll all get 26, but there's going to be a 3, just an extra 3. The reason that the 3 is extra is because we don't have enough to give 1 to each group. Like let's say we broke this 3 into 3 pieces. We could give each of these guys an extra 1, right? 1, 2, 3, but you can't just give some people the extra 3 and not everybody. It's kind of like if we really were sharing cookies and I had 14 friends that I was sharing my cookies with, and I had 367 cookies, and I gave everybody 1 until everybody had 26. Wouldn't be fair if these guys each got an extra 1, would it? All these other guys over here would be really upset. They didn't get the extra cookie. Okay. So that's how you do partial quotients. If there's any specific problems you'd like to see, let me know. I know this was a lot of information if this is a new strategy for you, but just watch it again. And again, leave me notes in the comments if you'd like to see something specific. Thank you.